Alright guys, here we go. We're going to try this. So, today we're going to talk about an easier way to divide. So on page 59 and 60 in our notebook, we're going to add some things. So on 60, we're going to put synthetic division, which this is the shortcut, and I'm going to go over with you a couple examples as to how to do that. However, the instructions are right on here if you're not sure. Okay, so go ahead and put that on page 60. On page 59, we're going to put our little poof book. So I'm going to fill that out separately, and then you guys can just tape it in after we're done. Okay, so synthetic division. Starting right here, we can only use synthetic division when we have linear factors. So can only use when dividing linear factors, which is kind of a bummer because if something is not linear, then you can't use this. So if it's like x squared or x to the third is what you're trying to divide into, then you can't do synthetic division. And this might not make much sense now, but hopefully it will in a minute. Don't forget to switch your signs, which I'll point out to you in a minute. Okay, so let's look at our first example. So right along the side here we have all of our directions. We can only use synthetic division with linear divisors, which we do have right here, so that's a good thing. So we're going to write the coefficients of our dividend in order of exponent, and we're going to make sure that we don't forget to put a 0 in for missing place values, which we had to do yesterday with long division as well. Okay, so here I have each of these numbers. 1, there's no to the third, so 0. -7, 9, and then -10. Then we put the 0 in over here, and it has to be the 0, so that's where the sign switching comes in. So switch signs. Like it looks like a negative, but we need to put in a positive right here, which makes sense because we're taking the 0 anyway, not the factor, the 0. And then we just follow the same process to divide it out. So we first begin by bringing the first value down. So 1 drops down. Then we multiply and then add. Multiply and then add. Multiply and then add. Multiply and then add. Your last number is always your remainder. If there is a remainder, that means it didn't divide evenly. So when I write out my answer here, everything is 1 degree less. So we were to the 4th power, so this is going to be to the 3rd, to the 2nd, to the 1st, and then nothing. And then we have to add in our remainder. So we'll have x to the 3rd plus 2x squared minus 3x plus 3 plus our remainder of -4 over our divisor. Final answer. It's nicer when things divide evenly. Okay, so pretty easy, hopefully. Now the cool thing is, if we don't want to divide at all, we can check to see if something is a factor or not using the remainder theorem. So if a polynomial is divided by a factor, then the remainder is actually equal to when we would plug that number in. So with that last one, if I had plugged 2 into my polynomial and I evaluated it, I would have found that I get -4, which means that there is a remainder, which means it's not a factor. And so that's what this factor theorem is saying. If the remainder is 0, then this is a factor. So for A, B, and C, we're going to try 3 different polynomials. We're going to see if the remainder is 0 or not to determine if the polynomial does have a factor of x plus 2. Now again, we have to make sure that we switch the sign because we're plugging in the 0, so x equals -2 really. So if I plug that in here, we'll do -2 to the 3rd plus 4 times -2 squared minus 5 times -2 plus 3. So -2 to the 3rd is actually going to be -8. Then we're going to have plus 16, plus 10, plus 3. And so when we add all those up, we end up with a remainder of 21, which means it is not a factor. I'm going to do the next one a little quicker. So if I plug in -2, we're still just trying to see if this is a factor. We'll do -2 to the 3rd minus 2 times -2 squared minus 40 times negative 2 minus 64. When all is said and done there, you should get a remainder of 0, which really means like when I do all this math here, it equals 0. So a remainder of 0, which means that it is a factor. And factors are so good, because then we can start factoring more. Lastly, if I plug in negative 2 to the third plus 6 times negative 2 squared plus 5 times negative 2 minus 12, when I evaluate this, when I do to the third and add all these numbers together, I end up with negative 6, which means I have a remainder of negative 6, which means it is not a factor. So that's kind of a cool thing. Like, you don't have to do that, but it's kind of a cool thing. Lastly, we want to use division to help us factor more efficiently. So if I know that I have a polynomial and a factor of that polynomial, I can divide it out so that I can factor more easily. Now this is a polynomial and maybe I could use the box method, but maybe they don't have anything in common so I can't factor right now. However, I do have this factor right here that I'm going to synthetically divide out, and then maybe I can factor. So let's take the opposite sign, our 0, so 5 goes in the box. Then we bring down our coefficients, so 3, negative 2, negative 61, negative 20. We didn't skip any exponents, so that's good. We don't have to have any zeros. Then we bring down the first number, multiply, then add, multiply, then add, multiply, then add. That last number, again, should always be your remainder. And since I have a remainder of 0, it is a factor, which we should have had anyways because they told me it was a factor. So now when I write this new thing out, my quotient, it will be 1 degree less, so x squared, x, and no x. And so if I'm writing this out in factored form, one factor was x minus 5. When I divided that out, this is the other factor now, so 3x squared plus 13x plus 4. And then that this is now a quadratic, I can probably just factor this like normal, where I slide divide bottoms up. So I get 12, trying to add to 13, so 1 and 12. So I have x minus 5, x plus 1, x plus 12, but then because we multiplied that 3, we need to divide it out. And so, final answer, we'll have x minus 5, 3x plus 1, and x plus 4. So that's basically it. Hopefully you find synthetic division to be a little easier. This little poof book, you're going to cover up example 4, unfortunately. Should go in on page 59, and then you guys can start your homework. Good luck.